Welcome to qnawire.
Okay. So, right, what you've got is something like this. And I'm going to simplify things because these don't really matter. They're just methyls or CH3, right? Uh, Methyl means CH3. Point is, you're supposed to be looking at this bond right there and looking down that bond with your eye, right? So ideally, you would use that little viewer and then change the, uh, drag the box around until you're looking literally down the bond between the second and third carbon, right? That's what you're supposed to be looking at. And if you were to do that, what would you get? Well, you're going to get not exactly what you've gotten there, right? So what you're going to end up with is the following: you're going to have your carbon that's in front, which, you know what? Let's color code this. I like to color code these. So this is blue, and we'll do the back in green. Okay. So in blue, we're going to be going right, and then green will be in the back. Okay. So down and to the left, you have a hydrogen. Down and to the right, you have a hydrogen. And then up, you have that methyl that's coming towards you. Right? At this point, we're drawing this one here. Okay. Now we look at the one in the back and we see, okay, there's a methyl that's going down. There's a hydrogen up and to the left, and a hydrogen up and to the right. So I guess just rearrange this drawing in the little viewer until it looks like this. This is really what you're looking for. Right. So the fact that there's 6 things and they're all separated by 60 degrees, this counts as being a staggered conformation. Right. So you need to go to the staggered tab. Right. And then you'll fill things out just like this. Right. You'll put CH3s on the top and the bottom, and then hydrogens all around. And then the question is, does this represent a local energy minimum or a global energy minimum? This is a global energy minimum. This is the lowest energy that we can get. Why is that? High energies are basically whenever we are staggered. So if we have like the case that you drew, right, no matter what we put here, these are always going to be higher energy than the Eclipsed. And then the next higher energy or the next lowest energy is going to be anytime these methyl groups are near each other, whether or not we're staggered. Like, so even if we were staggered, if we had, say, a methyl here and a methyl here, that's going to be higher energy than when we have the methyls far apart. So when things are staggered and the methyls are as far apart as possible, that's actually the lowest possible energy conformer we can get. So that's why this is the global energy minimum. This would be an example of a local energy minimum in that it's lower energy than the staggered versions, or sorry, the eclipsing versions that would be on either side of it, representing a rotation 30 degrees to the left, or 60 degrees to the left, or 60 degrees to the right. But it's not lower energy than all other conformations because, for example, this conformation here is the global minimum, right? And you can't be lower than the global, especially not if you've got methyls next to each other. Okay, hopefully that makes some sense.